All right, here we go. We're going to do the first 2 or 3 by hand, and then we're going to switch to Desmos, okay? So in order to do this by hand, a good skill to have, we need to start by getting the absolute value all by itself. So absolute value of 2x plus 1 equals, move that 3 to the other side because it's not in the absolute value, so 9. Okay, next step. That means that 2x plus 1 equals 9. That's good to know. It also means that 2x plus 1 could have equaled negative 9, but we had to make it positive, and therefore we'll just solve both of these. So subtract 1 from this, that gives me 8. So x could equal 4, which makes sense. Plug a 4 in, it works. And then 2x equals negative 10, x equals negative 5. There's our other solution. Okay, let's jump to the next one. By the way, totally could have graphed it from the very beginning. Y equals the left side, y equals the right. Find the points of intersection. That is faster. These are good skills to have too. Okay, before we ever begin this one, let's solve for the absolute value, meaning we need to start with that on one side by itself, which means we need to divide by 2. So there's that. Okay, absolute value is by itself, so x minus 1 could equal 4. X is 5. There's one answer. And x minus 1 could have equaled negative 4, so x is negative 3. There's the other answer. Okay, totally could have graphed it too. All right, the next one. How about we just start graphing them, okay? Let's do it. For the next one, what I'm going to do is say y equals this side. I'm going to do y equals this side, and I'm going to do y equals that side, and we're going to solve and find where they meet. So y equals the left side, y equals the right. Well, are you going to move that 2 over first? Yeah, if you want to. Feel free. I'm not. You do need to get the bars by themselves if you're solving it by hand. Desmos, not so much. Okay, so here we go. Y equals the left side, absolute value of negative x plus 7, and then plus 2. So there's that. And then the next one is y equals 7. And it's not showing up. I have to zoom around a little bit and find all the points of intersection. Let's make them a little bit bolder. There we go. And so there's a point, and there's a point. Now you might be tempted to pick that one. No, that's an x-intercept, a y-intercept. Nope, I need where they intersect. The two graphs intersect, and that's at 2, 7 and at 12, 7. However, the actual equation was, hey, tell me what x is. All I care is the 2 and the 7. So that's the answer to this one. It's just 2 and 7. So I did y equals this, y equals that. Final answer is x equals 2 and x equals 7. Okay, I'm not going to do the next one on the computer. What I am going to do is start this one by hand. If we subtracted 3 from both sides, we would have absolute value of x plus 2, and it would equal negative 2. What do you notice? Absolute value equals a negative? No, it doesn't. No solution. Okay, sometimes you have one answer, sometimes you have 2, sometimes you have none. So we're going to type this one into Desmos. Very quickly, we're going to crank out a couple answers. Again, this will be y equals this side, and this will be y equals that side, okay? And we'll do that. Let's just go ahead and do the same thing over here. So y equals this, and y equals that. We're going to see where they intersect. We might have to zoom around and find them. It's a beautiful way to do some of these by hand. We're not going to go there right now, much as I would love to. It would be lots of fun, but we're not going to. Okay, let's keep what we had. And we had x plus 2 there. And the other one is 3x minus 8. And I'm going to go to a standard zoom. And I think we could tell that they intersect once, and it's right up here. So let's drag that down, find where that is, and the answer is 5 at x equals 5, and that's the only place. So again, sometimes they only meet once. So x equals 5, I'm writing that on my paper. You'll see my paper in a minute. And then the final problem, by the way, again, you could do this one algebraically. I'd love to go into it. I'm not going to right now. Ask me someday. It's lots of fun. Okay, this one looks like it meets once, so x equals 3. But I do want you to notice this one, you've got to be careful. Notice the slopes. These two, this piece and this piece, they kind of tilt towards each other. So there's another point of intersection up here. So 3 is one of the answers, but the other answer is there. So you have to know where to look. Negative 11. So 3 and negative 11. So x equals 3, x equals negative 11, in no particular order. Okay, I think I do have time, so very quickly, I do want to show you how to do this one by hand. I'm just itching to do it. So if you wanted to do one like this by hand, you could do x plus 2 equals 3x minus 8, just like we did algebraically on the other ones. But you know how I said you're going to have to change the sign? X plus 2 equals negative 3x plus 8. I would do the opposite of that, and I would solve both of these. And that would give me, let's see, 2x equals 10, so x equals 5. So far, so good. And then 4x equals 6, so x equals 3 over 2. And here's the deal. If I plug 3 over 2 back into the original, I don't get a true statement. Let's try it. So the absolute value of 3 over 2 and then plus 2 equals 3 times 3 over 2 minus 8. And this is going to give me a false statement, basically. So I'm going to have, let's see, that's 3½ over here on this side. And this side is 3 times 3 halves minus 8. It's going to give me negative 3.5. So this one is an extra solution. Technically, the mathematical word is extraneous. So we had to throw it away. Extraneous, like too much.